Hey there, and welcome. We are about to go on a step-by-step journey into the world of serverless Ruby. We're going to cover everything, how to write it, how to package it, and how to get your code running on AWS Lambda. So let's just dive right in. So let's start with the big question, right? You love writing Ruby, but are you tired of the whole song and dance with servers? The provisioning, the patching, the scaling. What if you could just focus on your code and let someone else handle all that infrastructure stuff? Well, that's the whole promise of serverless. At its heart, a Ruby Lambda function is pretty simple. It's your script, your code, just living inside a fully managed environment that AWS handles for you. The AWS SDK is already baked in, so it's ready to go, processing events from things like API calls or database changes. And the whole thing runs under an IAM role, which is basically just you telling AWS exactly what your code is and is not allowed to do. You're in complete control. Okay, first things first. We gotta write some code. And in the Lambda universe, every single function starts with one absolutely key piece, the handler. Think of the handler as the front door to your code. It's the main entry point. Whenever something happens that's supposed to trigger your function, Lambda knows, okay, I need to find this specific method and run it. It really is the heart of your entire serverless function. And what's great about this is just how simple a basic handler is. It's just a Ruby method, nothing fancy. Notice those two required arguments: event, which is a hash that holds all the incoming data from whatever triggered the function, and context, which is an object with all the runtime info. And then the method just returns a hash. This part's super important for things like API Gateway, which needs that status code and a body to send back to the user. All right, so our code is written. The next big step is getting it ready for AWS. You can't just upload a .rb file directly. You have to bundle it all up into a proper deployment package. And you've basically got two main ways to do this. The classic method is a .zip archive. Think of it like mailing a small parcel. It's simple, it's direct, and it's perfect for smaller projects. Then you have the modern approach, using a container image. This is more like using a custom-built shipping container. It gives you absolute control over the environment, which is fantastic for really complex apps that need specific system libraries, like, say, if you're doing image processing with ImageMagick. So let's go down that first path. How exactly do we bundle our application and all its gems into a single, neat little zip file? It's actually a pretty straightforward four-step dance on the command line. You start a new gem file. Then, and this is the most important part, you tell Bundler to install your gems locally, right there inside a vendor/bundle directory. After you run bundle install, you just zip up the entire project folder and boom, there's your deployment package ready to go. Now, there are a few gotchas here to keep in mind. Your package has size limits and needs the right file permissions, and your main handler file has to be at the very top level of the zip. But here's the one that trips up almost everybody at some point. If you use gems that have native C extensions, you must build them in a Linux environment that perfectly matches Lambdas. If you don't, you're going to have a bad time with runtime errors. Okay, on to the other path. Let's see how we can package our function as a container image, which gives us a ton more flexibility. With this method, everything starts with a Docker file. And honestly, that first line is the most important one. You use the from instruction to pull an official base image from AWS. This is awesome because it gives you a huge head start. It's already got the right Ruby runtime and the special client that lets Lambda communicate with your code. So once you have that base environment set up, you just need to get your own code in there. The copy command does exactly what it says. It copies your handler file into the special Lambda task root directory inside the container. And the last piece of the puzzle is the cmd instruction. This just tells Lambda what the default command is when your container boots up. You're pointing it right at the file in the method that acts as your handler. Simple as that. Let's look at the whole workflow here. You build the image right on your own machine. Then you push it up to Amazon's Elastic Container Registry, or ECR. And finally, you create your Lambda function in the console and just point it to the image you just pushed. It's a really clean and, more importantly, repeatable process. Okay, so your function is deployed. Awesome. But is it fast? Let's switch gears from deployment to optimization and talk about some pro tips to make your code way more efficient. These are all fantastic habits for writing solid code, but the one that has the biggest, most direct impact on performance and cost is that second one. initialize things like database connections outside of your handler method. Why? Because it lets Lambda reuse those connections on what we call warm invocations. This means you skip the expensive setup cost every single time, which can make a dramatic difference in speed. And speaking of speed, if you're on Ruby 3.2 or newer, you have a secret weapon, YJIT. It's a just-in-time compiler that can give your code a serious performance boost. The trade-off is slightly more memory usage, but it's especially powerful for bigger, more complex applications that feel a bit like a Rails app. And you know what the best part is? Turning on this super powerful feature could not be easier. You literally just set one environment variable on your Lambda function, and you are good to go. So our function is deployed, and it's optimized. The final stage of this whole journey is making sure it's actually running smoothly out in the wild. We need to know how to monitor it. One of the best things about Lambda is that basic logging is just handled for you. You don't have to set anything up. Every put statement, every error, every bit of runtime info, it all just automatically flows into a dedicated log group over in Amazon CloudWatch. At the end of every single run, Lambda adds this little report line to your logs. And this thing is a gold mine. Duration tells you how long your code actually took to run, but build duration is what you actually pay for, rounded up. And then there's init duration. That's the cold start time. It's that one-time cost for spinning up a brand new environment, and you only pay it if your function has been sitting idle for a bit. Now, when your standard logs just aren't cutting it for a really tricky bug, you can level up to AWS X-Ray. You just flip a switch to enable it, and you can trace a single request as it weaves its way through your function and any other AWS services it talks to. It gives you a complete map of any performance bottlenecks. So there you have it. We've gone through writing, packaging, optimizing, and monitoring your Ruby code on Lambda. You've got the tools, you've got the knowledge. So really, the only question left is, what amazing thing are you going to build next?